Write equations of ellipses from their graph. If we're given a graph and we want to find the equation of ellipse, we know the standard form. And why is the standard form important? Well, the center is HK, which would be right about here. And then once we identify the major axis, we know that this distance right here is A. And when we identify the minor axis, we recognize this distance right here is B. So the distance from the center out to the vertices is A, and the distance from the center out to the co-vertices is B. So when I go ahead and take a look at this particular graph, I can clearly see my major axis is right along here. It's horizontal, isn't it?
Yes.
All right. So what is the halfway point along that axis if I extend from one vertice to another vertice? I want to say it'd be right about here.
Yeah.
And what is the coordinates of that point?
That would be 6, 7.
I'm going to write that in. 6, 7. So that means the h value is 6 and the k value, well, that would be 7. Now, along the major axis, how far do I extend left and right from the center out to the actual vertice? What is this distance right here?
Is it 5?
Okay, because you're going from 1, 7 to 6, 7. So that distance right there is 5. Very good. So that value of A is 5. A squared would be 5 squared. How about the distance along the minor axis from the center out to the co-vertices? What is this distance right here?
That looks like 3.
Because that's a distance where you're going from 6, 7 to 6, 10. 7 to 10 is 3 units.
Right.
So B is 3. B squared would be 3 squared. There's my equation. We can write it out with all the gusto in the world now, huh? We got x minus what? X minus?
Minus 6.
Quantity squared over what? Over?
Over 25.
Very good. Plus, because we have an ellipse, plus what?
Y minus 7 squared.
Good. Over what? Over?
Over 9.
Very good. And it's set equal to?
1.
1. And we have our equation from our graph. Thank you, and thank you. We want to find the standard form equation of an ellipse with the following vertices and foci. Let's start with the vertices. Well, we know the vertices are plus and minus 8, 0. So in our language, that's plus and minus a 0. This immediately tells us that our equation of the ellipse is going to be x squared over a squared plus y squared over b squared equals 1. And that's because we know that plus and minus a is going to be that x coordinate. Next thing we're going to do is recognize the foci are plus and minus 5, 0. So in our world, that's plus and minus c0. So let's see what information we have. We know that a is equal to 8. So a squared would be what? It would be 64. What we have to do is figure out what b squared is. To do that, we have a relationship that c squared is equal to a squared minus b squared. Well, I know c is 5, so c squared is 25, and I know a is going to be 8, so a squared is 64. So now I have 25 is equal to 64 minus b squared. And I'll just solve for b squared. I'll subtract a 64 from both sides of the equation, leaving negative 39 as negative b squared. And if I divide both sides of the equation, I find that 39 is equal to b squared. I don't need to solve for b, I need to solve for b squared. b squared is 39. Well, that's the last piece of information I need to know. I know that my equation of the ellipse will be x squared over what? Over 64 plus y squared over 39 is equal to 1. Let's graph the ellipse that's given here and identify the center vertices, co-vertices, and foci. So first thing I do is I realize since 25 is greater than 9, then the general form is x squared over b squared plus y squared over a squared equals 1, and that the y-axis becomes my major axis. So as I sketch my two axes, here is the y-axis, and here is the x-axis, I realize my major axis, which again is the y-axis, I'm going to identify the y-intercepts, and that's plus and minus the square root of 25. So that's plus and minus 5. So I'm going to go ahead and place a point here and here, and just label 5 and negative 5 along the y-axis. Along the x-axis, to find the x-intercepts, well, that would be plus and minus the square root of 9, or plus and minus 3. So I'll go ahead and put points approximating where that would be. So I have 3 and negative 3, and I'll try to draw the ellipse. So with the ellipse sketched, let's see if we can identify the information that we need to identify. First of all, just for the center is at the origin, so the coordinates would be 0, 0. For the vertices, well, that's your y-intercepts that we're seeing along that major axis. So the coordinates there would be 0, 5, as well as 0, negative 5. So for my vertices, I'll write it as 0, plus and minus 5, which notice is the square root of 25. For my co-vertices, I'm looking at the x-intercepts, and if I take a look at those, the coordinates there are 3, 0, as well as negative 3, 0. So for my co-vertices, the coordinates would be plus and minus 3, 0. And notice again here, that is going to be what? That's going to be the square root of 9. Lastly, I have to find the foci. Now the foci will occur along the major axis, and to find the foci, we take the equation c squared is equal to a squared minus b squared. And we know what a squared is, that's the 25, and we know what b squared is, that's the 9. So it looks like c squared now is equal to 25 minus 9, which is 16. Which means to find c would be the values plus and minus 4. And since these foci occur where? Along the major axis, if I go to label them and write in their coordinates, you're looking at 0, 4, as well as 0, negative 4. There are my foci. The coordinates would be 0, plus and minus 4. Find foci vertici, centers, axis lengths, eccentricities, or intercepts of ellipses. An ellipse, we know, it's a set of all points in a plane such that the sum of the distances from two fixed points is a constant. And those two fixed points are called the foci. So to imagine the foci, imagine going ahead and taking 2 points, which you see here and here, and creating a rubber band that simply goes from one point to another. And if you go ahead and just stretch the rubber band to its natural length and trace, you'll trace out an ellipse. So every ellipse has the following, and I'm just going to trace this through with you. It has a major axis, which we're seeing right here. And then the endpoints of the ellipse along the major axis are the vertices, which you see here. Now, the foci occur along the major axis, which you see here. Along the minor axis, that's the shorter axis that you see here, you'll have the co-vertices where the intercepts hit the minor axis. And then the center of the ellipse, well, that's where the major and minor axis are perpendicular. And that center of the ellipse you see right here. Well, for an ellipse that has this particular standard form, what we know is that the major axis is parallel to the x-axis. And that's when A is greater than B. So if you and I are going to just recognize some pieces of information, first thing I'm going to do is sketch the major axis, which I'm seeing right here. Now the center is HK, so I'm going to put an H here and a K here. and mark it. Now, if I go ahead and think about the fact that this particular ellipse is stretched left and right a maximum of a units, then the coordinates of my vertices, well, notice, if you will, the y-coordinate is k, but the x-coordinate would be h plus a. You can see this goes a over h and then over another a. And the other vertice, which is here, has a y-coordinate of k, and would have coordinates, I guess, we'd go ahead and say h minus a. Now, also along the major axis are the foci. And those foci, if I drew them in, would be located approximately here and here. And the way you find the foci is you go ahead and calculate a value of c, which is a squared minus b squared. And the coordinates of the foci, well, you go ahead and take a look at foci 1, its y-coordinate is k, and then that value of c is your distance from the center over to the foci, which is c units. So it would be h minus c, comma k, and h plus c, comma k. Now, along the minor axis, I believe we were doing that in blue. If I go ahead and sketch my minor axis, I have my vertices. Well, if I go ahead and take a look at the distance from the center going up and down, that would be b units. So if I go ahead and place my co vertices here and here, notice the x-coordinate is h, but the y-coordinate would be k plus those b units and k minus the b units. So I'd write k plus b, k minus b, or h, comma, k minus b. So you say, all right, so we're able to label an ellipse that has a major axis that's horizontal. How about an ellipse that has a major axis that's
not horizontal?
Which would be vertical.
Oh.
Okay, so now I have to change my perspective a little bit. My major axis, being vertical, is located right here. Now I know the center is given by coordinates what? Given by coordinates
HK.
HK. So I'm going to place the center right here, which would mean this is H and this is K. Now I have to think about this. We're stretched in the Y direction more than we're stretched in the X direction. We're stretched vertically more than horizontally. So we're stretched upward and downward. How many units?
A.
A. Good. So my equation to represent the coordinates of the vertices, well, X-intercept is H, but the Y-intercept would be K plus what? K plus?
Plus A.
And the other vertice would have coordinates what? H, comma?
H. And then K minus A.
Very good. Now what all else falls along the major axis? The
foci.
The foci, very good, which I'll call F1 and F2. And do you remember what variable we used to represent the distance from the center to the foci?
C.
C, very good. Now my x-coordinate is H, and then to find my foci that's above, I guess I would take K plus C. What would be the coordinates of the other foci?
Would it be H and then K minus C?
Very well said. All that's left is to look along now we've looked along the major axis, so now we need to look along the
minor axis.
Minor axis, which is right here. And I want to look at the co-vertices, which are here and here. Now the co-vertices have a y-coordinate of K, and then I have to think, how far horizontally have I gone from the center? That would be what? It would be?
B units?
B units. So my co-vertice on my right would be what? H plus
plus b.
Plus b, and the co-vertice on the left would be
H minus b.
h minus b, comma,
K.
k. Very, very good. Thank you, and thank you. Let's graph the ellipse given by the equation shown below. We will identify and label the center vertices, co-vertices, and foci. We're given 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. So the first thing I'm going to do is just set up my coordinate axes. I'll label my x-axis and my y-axis. Next thing I'm going to do is put my equation in standard form. So that means I'm going to group the terms with x, I'll group the terms with y, and I'll move my constant by subtracting 100 to both sides of the equation to the other side of the equation. So grouping the terms with x and factoring out the lead factor, I have 4 times x squared minus 10x, and then I'm going to have plus a blank because, again, I'm going to complete the square on this first trinomial. Similarly, I'll group the terms that contain a y and at the same time factor out the leading 9. This gives me 9 times y squared plus 4y, and again, because I'm completing the square, I'll put plus a blank. Now recall, I'm going to subtract 100 from both sides of the equation, so this is equal to negative 100. Now for completing the square, I take half of the middle term, and I square it. This gives me negative 5 squared, which is 25. But that 25 is located in parentheses, so I really have added 4 times 25 to the left side of the equation. So I'm going to add to the right side of the equation 4 times 25, and that's 100. I'll take half the middle term again, half of 4 is 2, and square it. And I'll place the 4 in this blank, but again, that 4 is located in parentheses. I've really gone ahead and taken 9 times 4, which is 36, and added that to the left side of the equation, so I'll add it also to the right side of the equation. So what would my next line look like? Well, I would have 4 times x minus 5 squared, because this is a perfect square binomial, plus 9 times y plus 2 squared. And on the right side, negative 100 plus 36 is just 36. To complete the process of putting this conic in standard form, I want to take my constant and set it equal to 1. So I'll divide everything through by 36. So my standard form looks like x minus 5 squared over 9 plus y plus 2 squared over 4 is equal to 1. Now from here I can read off some information. For example, I can take a look within the parentheses and realize my center is 5, negative 2. I'm just setting the parentheses equal to 0 and solving. So I'm going to go ahead and plot that point, 5, negative 2. Now, because I have these two terms being added, I know I have an ellipse. And in the direction of x, we have a distance of the square root of 9, which is 3 units, shifted from the center to form the vertices. 3 units left of 5 would be 2, so one vertex is at 2, negative 2. 3 units right of 5 would be 8, so we have 8, negative 2, and the location of the 2 vertices. So along the x-axis, I'm just going to label that 2 and that 8. Now from the center, I will shift the square root of 4 in the vertical direction. So for my co-vertices, I'll have 5, comma, and I'll shift up 2 from negative 2, 5, comma, 0, and down 2 from negative 2, 5, comma, negative 4, for my co-vertices, and then I'll sketch in my ellipse. Well, my last task is to find the foci, which I'll label along my major axis. To find the foci, what I'm going to do is remind myself that c squared is equal to a squared minus b squared. So c squared is equal to a squared, which is 9, minus b squared, which is 4, and that's 5. So c is equal to plus and minus the square root of 5. So again, moving from the center, both left and right, I will move the square root of 5 units over. So my foci, they'll be located at 5 minus the square root of 5, comma, negative 2. And that would be the foci located right here, as well as 5 plus the square root of 5, comma, negative 2, and that would be the foci located right here. Given the graph of the ellipse, determine its equation. Let's start by writing out the standard form of the equation of an ellipse, which is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now first let's just recognize what the center HK would look like. Well, the center HK would have coordinates 0, 0. So we'll place a 0 here and a 0 here. As far as A is concerned, A will tell us our distance from the center out to the co vertices. And that distance looks like it's 4. So we'll place a 4 in for A. What does B tell us? Well, B will tell us the distance from the center out to the vertices. That distance looks like it's 6. We can now write our equation of our ellipse, which would be x minus 0 squared over 4 squared plus y minus 0 squared over 6 squared equals 1. Simplifying, we get x squared over 16 plus y squared over 36 equal 1. And we're done. Graph ellipses. If I want to graph ellipses in the form of x squared over a squared plus y squared over b squared equals 1, they all share a common feature. And the common feature they share is that the center of the ellipse is at the origin. And then the ellipse is stretched in the x direction, a units to the left and a units to the right. So my coordinates here would be a0 and negative a0. And they're stretched upward and downward b units. So my coordinates along the y-axis would be 0b and 0, negative b. And I have my ellipse. Now if you're wondering why, just off to the side, I can show you very quickly. If I go ahead and find my x-intercepts, then y is 0. And we end up with x squared equals a squared. And my x-intercepts are plus and minus a. And the same thought process would hold if I'm trying to find the y-intercepts. X would be 0. So then I'd have 0 plus y squared over b squared equals 1. And then y squared equals b squared. And so my y-intercepts would be plus and minus 0, or 0 plus and minus b. So that makes graphing these pretty quick. Easiest question I'll ask you today is, what's the center of this particular ellipse on the left?
0, 0.
0, 0, the origin. How far do I stretch in the x direction?
7 units.
7 units, very, very good. So it's the square root of 49 being 7. That tells you that you'll stretch in the x direction 7 units. You'll have 7, 0 here. And negative 7, 0 here. And how far do I stretch in the y direction from the origin?
3 units.
Square root of 9, which is 3. So my coordinates here would be what? They'd be, I want to say
0, 3.
0, 3, and here would be
0, negative 3.
0, negative 3. Then I just sketch my ellipse. So I'll just go ahead and sketch it. Very quick to do, isn't it? Let's do it again. Take a look at the equation of the ellipse on the right. And how far would I stretch in the x direction?
2 units.
2 units, which is the square root of 4. So the coordinates I want to say would be what for those x-intercepts?
2, 0, and negative 2, 0.
Very well said. And how far would I stretch in the right here?
10 units.
Sorry, how far would I stretch from the origin up and down?
10 units.
10 units, and that's the square root of 100. So what would be the coordinates of the y-intercepts?
It would be 0, 10.
Okay, and
then 0, negative 10.
0, negative 10. You said negative 10. Be good if I wrote it. And then I just sketch my ellipse. And I have it sketched. Let's do one more. When I have an ellipse in this form, the center is no longer the origin. The center is found by imagining, if you will, that x minus 5 is in the form of x minus h. And so the x-coordinate of the center is what we're calling h. Well, when I go ahead and read off my center hk would be what? It would be
5, 4.
5, 4. So I can plot that, I suppose, pretty quickly. I'll go right 5 units, up 4 units, and plot the center. Now, same set of questions I had a moment ago. From the center, how far do I proceed to place my endpoints along the major axis? It's called the vertices. How far do I go from that center, left and right?
Would it be 7 units?
7 units, very good. So what is 5 plus 7? That's what? That's
12.
12, okay? And 5 minus 7 is?
Is negative 2.
Negative 2, very good. Now, for the co-vertices, how far do I stretch from the center, or go from the center, upward and downward?
3 units.
3 units, very good. So I was at 4. If I go up 3 units, I'm now at 7. And if I go down 3 units, I'm at what? I'm at
1.
1. Excellent job. And when I sketch in my ellipse, I have it right here. Thank you and thank you. Write equations of ellipses given their centers, foci, lengths of axes, eccentricities, and vertices as needed. Little bit of a reminder. We have an ellipse. So the major axis is the one such that the distance from the center is greatest to the ellipse, and along the major axis are the 2 vertices where the ellipse meets that axis, and the 2 foci which helps us define our ellipse. Now the axis perpendicular to the major axis, that's called the minor axis. And along the minor axis, where the ellipse hits the minor axis, are the co-vertices. And smack in the middle of the ellipse, we have the center. Now what I want to do is write the equation of this ellipse given these vertices and foci, which may look kind of daunting to you. But what I want to do is just remember my general form and kind of fill it in as I go. So the first thing I'm going to do is I'm going to start by just sketching. If I will, I'm going to sketch my vertices. My vertices are at 6, negative 1, so I'll put a point there, and 6, negative 13. And I'm going to use them to write the standard form of the ellipse. Now I know they're located along what? Along the major axis. I'm just going to gently dash it here. Okay, there's my major axis. And halfway between them is located the center. Well, that's pretty cool. I can find the center pretty quick. Center seems like it's at x equals 6. And the y-coordinate would be halfway between what two values? Halfway between?
-1 and -13.
All right, so I'll take -1 plus -13 and divide by 2. So it looks like my center is given by 6 comma -14 over 2 or -7. And I can plot that very clearly right here. There's my center. But I can now start to write the equation of the ellipse, because I have x minus h, which would be -6, squared over a number, plus y minus k, which is -7, so that's y plus k, or y plus 7 squared over a number, equal to 1. Getting closer. Now the major axis, is that vertical or horizontal?
Vertical?
Vertical. So I notice then that I can very quickly find out what A is, because A is nothing more than the distance that I have from the center out to what? Out to the vertice. And what is that distance? That distance is?
That distance is 6.
Because you're going from -7 up to -1 or -7 down to -13.
Right.
So I'm going to write down here that now we're over 6 squared, which is?
36.
36. Now the last thing I have to do is find b squared. And to find b squared, I know I have a relationship that it comes from, of all things, the foci, which says that c squared is equal to a squared minus b squared. Now c is just this variable that helps us locate the foci. And the foci is located at -7 plus 4 square root of 2 and -7 minus 4 square root of 2. So I'm just going to write that out. My foci is given by 6. How about -7 plus or minus 4 square root of 2? What is 4 square root of 2 approximately?
It's about 5.7.
All right, so it's a little more than 5 units up from -7, maybe here. A little more than 5 units down from -7. -7 minus 5 is negative about here. There's the foci right there. The point I'm trying to make is that when I take a look at the value of x equaling 6, that makes sense. It's along that vertical line. But to find the foci, this distance here I can see. It's 4 square root of 2. That's my c. That's what I'm trying to say. That's my c. So if I know c is 4 square root of 2, and I'm squaring it, and a we found, that was what? That was?
A was 6.
So I got 6 squared minus b squared. I can find b, can I?
Yes.
4 squared is?
16.
16 times -2, or 16 times 2 is?
32.
32, very good. And 6 squared is?
36.
36, very good. So it looks like -b squared is what? -b squared is?
Is -4.
Okay. And what would, let's see if I can write -b squared here. Writing everything but -b squared. What's b equal to? What do we get if we divide by -1? 4 equals b squared. What's b equal to?
2.
And b squared would be?
B squared would be 4.
Be 4. Beautiful. And we have our equation of our ellipse. And, although we don't have to, if we wanted to finish graphing it, what would we do? We would go 2 units left and right of the center along the minor axis, and you can see the ellipse clear as day. And let's go to highlighter mode and see if we can sketch our ellipse in blue. You would go through the co vertices and the vertices, bypassing the foci, and it would look just like that. Thank you and thank you. Represent ellipses as equations of the form x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. This is my standard equation for an ellipse. Why is the form important? Well, from the form, I can take a look at hk, and I can realize I have the center of the ellipse right here. Then I can take a look at the value of a and realize that along my major axis, I will go from the center a units both left and right. And I can look at the value of b and realize along my minor axis I can go from the center upward b units. And I can see the ellipse very clearly. So let's try to get this particular ellipse's equation in the form that's our standard form. To do that, we have to form perfect square binomials. We have to complete the square not once but twice. All right. So to do that, we're going to go ahead and rewrite our equation. I'm going to factor out a 9 from the first two terms with an x. So that'll leave me x squared plus, I guess it would be minus 8x. 9 times negative 8 is negative 72. Plus some value that I'll get back to later. Then I'll go ahead and complete the square on the terms with a y. So I'll factor out the 25. And that leaves me with y squared. Let's see, 25 times 4 is 100, is that right?
Yes.
Yeah.
Plus 4y plus a number. And then at the same time, I'm going to go ahead and take that constant and I'm going to subtract a 19 from both sides of the equation because I want to put my constants on the right side and eventually turn them into ones. Now to complete the square, just so that we remember, I take half the middle term, which is negative 8, half of it is 4. Square it, that's 16. Calculator time. What is 16 times 9? That'll add to the right side. Because if I put a 16 on the left side, it's really 16 times 9. So I have to put that 9 times 16 on the right side. What is that?
144.
Very good. Then I'll take half the middle term. So that's half of 4, which is 2. And square it and get back what? Get back?
4.
4. But I'll go ahead and add to the right side, not 4, but 25 times 4. Well, that's what? That's
100.
All right, so I got plus 100. All right, let's see if we can go ahead.
Do you subtract that, or is it plus?
Well, let's see. On the left side, I added 100. So on the right side, to balance it, I'll also add 100, and that'll keep that equation equal.
I see.
So what do we have? Well, what we have is 9 times, and I'm going to factor my x squared minus 8x plus 16. But it's always x and then this half of the middle term. So x minus 4 squared. Now, plus, then I have 25. And again, I'll factor, but it's always, in this case, y plus half that middle term, y plus 2 squared. And then on the right side, what is negative 19 plus 144 plus 100?
225.
Beautiful. Now to place this ellipse in the correct form, if I think about this for a moment, I need to set this equation on the left equal to what? Equal to?
To 1.
To 1. So if I want to go ahead and create a 1 here, what will I divide both sides of the equation by?
225.
225. So I'll divide the left and right side by 225. And that would be the same as just dividing the constant by 225. Now all we have to do is reduce. How many times does 9 go into 225?
25 times.
Beautiful. And how many times does 25 go into 225?
0.111. Repeating.
Is it 9 times?
9 times. Very good.
Oh, I did it backwards.
You did it backwards, didn't you?
Yeah, I did.
And what's 225 divided by 225? Even if you do this backwards, you'll get it right. What's that?
1.
1. Sorry, that was a joke. So here's my standard form. And when I see the standard form, do I see that ellipse?
Yes, we do.
Yes, we do, because the center would be 4, negative 2. Mark it. Okay. And then I'll go from the center to the left, square root of 25, which is 5, and I'll go upward from the center, square root of 9, which is 3. Thank you and thank you. What is the standard form of the ellipse with the following vertices and foci? The vertices are negative 2, negative 8, and negative 2, 2, while the foci are negative 2, negative 7, and negative 2, 1. I'm going to start by writing the standard form of an ellipse, and that's x minus h squared over a squared plus y minus k squared over b squared equal 1. And what I have to do is find out what the center hk is, as well as the values a and b are. So I'm going to start by finding out what h and k are. I'm going to sketch axes, my x-axis, y-axis, and I'm going to start with my vertices. I have one vertice at -2, -8, so I'll place a point here, and a second at -2, 2. I'll place a point here. Now for my foci, they're located at -2, -7. So I'll place one of the foci here and the other one at -2, 1. I'll place the second foci here. And I'll sketch in my ellipse, but I really don't know how wide to make it, so I'll just approximate it right here. And I'll take a look right along the major axis where the vertices lie. Because it is along the major axis that I'll find HK. I'll find the center of my ellipse, HK. Now by inspection, I see that H is -2, and I have to find K. But see, K will be halfway between 2 and -8. So 2 plus -8 divided by 2 is -6 divided by 2, and that's -3. So I do have H and K. H is -2 and K is -3. Now let's write the standard form as we have it up till now. We have x minus a -2, which is x plus 2 squared over a squared, plus y minus a -3, or y plus 3 squared, over b squared is equal to 1. Now I have to find a and b. Now remember, my center of my ellipse was at -2, -3. So I'm just going to mark that y-coordinate as -3. And I'm going to turn my attention to b. B is the distance, and it's a vertical distance, from the y-coordinate of the center to the y-coordinate of either one of the vertices. So it's the distance from -3 to -8. That distance is 5. Now we have to find A. Now I do have an equation that says that when I look for A, which is the distance from the center of my ellipse to either co-vertice, here's A, then I'll take C squared, which will be equal to B squared minus A squared, where C is given by the distance from the center to either of the foci. Well, that distance is the distance from -3 to -7. That's 4. So I have 4 squared is equal to B squared, which is 5 squared, minus A squared, and I can find A. I have 16 is equal to 25 minus A squared. So this means that 9 is equal to A squared. Beautiful. If 9 is equal to A squared, it looks like A would be 3. And now I can write my standard form of my ellipse. Standard form of my ellipse would be x plus 2 squared over 3 squared, which is 9, plus y plus 3 squared over 5 squared, which is 25, and that's equal to 1.